Well, let me share my screen too while there we go. Okay, so we are on not week 10, day one. Let me pull up my other calendar. We're on week 8, day one. But today we are going to be doing some more schema design, just like you did on Saturday. I am basing this off of this README. However, I'm going to walk through separately. We're going to flesh this out a bit more than just going through the README and having all the answers handed to us. We're going to think about this on our own. It is based on this restaurant DB, which when you open it up, oh, that's not hidden. Our end result will kind of look like these files. But again, don't peek if you want to actually try to challenge yourself today. We're going to walk through it and I'm going to ask for ideas and suggestions from y'all. So if you absolutely have to follow along, you can though. No harm in that. But we're going to design a restaurant today, a database that can be on the back end for a restaurant. And first things first, what we need to do to design this schema for our database, which is our collection of tables and relationships between them, is we have to think about how we want this database to look, like what, and we call it entities, what entities we're going to have in this. I'm going to scroll down real fast so you don't get everything all on the screen there, but we gotta think about what we want, what our restaurant does, what kind of information it stores, and kind of some general rules around that information as well, if that makes sense. A lot of times when you're working with a project manager, this will be the phase that they call requirements gathering, and you'll sit in requirements meetings where they kind of, you go through user stories and how your application is going to look and work, and that in turn translates to what you need to design for your database schema as well. There is a tool we're going to use to help put this together visually that's very nice, and it gives us these images here like that. You can find the link either by just Googling quick database diagrams, or if you go down for a challenge for the day and click into there, it'll bring this up and it says visualize the schema in this quick database diagrams. When you click that, it opens up this. So I don't know if you used this on Saturday or not. This is a very fun, I don't know. I think it's fun, but it's a very nice visualizer for your database schema, and it can help you kind of work out your relationships between all of your tables. It's free, and it says that right there. All you got to do is try the app. The only thing is, it's particular about how you write your tables in this text editor. So you can, let's see, where is it? File, load sample diagram. Yes, proceed. And what that does is it puts up almost kind of what we're going to be doing, but it gives you an example of how to lay out using the syntax that this editor expects. It's not that hard. We'll just kind of, you don't need to know how to use this right now. I'll walk through using it as we go through it, but it's kind of nice to use this instead of just throwing it up on your VS Code and writing your tables that way. This way we can see our tables and draw lines back and forth between them to help visualize. So we're going to erase that and we're going to figure out for our restaurant what our entities are going to be for our database. Oh, that's not what I wanted to do. So what tables, what's some things we're going to need for a restaurant? Okay, so here we can start thinking about like assuming what happens at a restaurant, right? So we assume customers come in, they order food off of a menu, and they pay for that food at the end. Each menu item has a price, right? So that's kind of my assumptions with this restaurant. It's a normal restaurant. We're going to have customers, we're going to have food, we're going to have orders, we're going to have prices set on stuff. Um, so what is probably one of the first tables that we definitely think we'll need here to hold some data for us? I don't have my check.
Customer name.
Customer name. Okay. Let's get even more broad and just have customers, right? We're gonna have a table of customers information. So I can have their name, maybe email, I don't know, whatever else we want to throw in there. So we'll do, I like that. We have a customer table. Or just put two dots in there. Okay, so here's one table. We'll come back and figure out what kind of fields we want in this table afterwards. We'll just kind of set up the basics of what other tables we're going to have. So I see he says food menu and drink menu. That is good ideas. I don't want to get that detailed today though. I do like having separate menus, but in this example, I guess we're not even going to have a menu. We're We can. Let's throw one in there. It's going to have a few more connections than we're intending to, but that's fine. When it comes to seeding data, it'll get interesting. Okay, so we'll have a menu. What else do we have? What does the menu have on it? Are we going to, for each like entry into this menu database, are we just going to have food items listed in rows, or how are we going to handle menu items, do we think?
Like appetizers, entrees, beverages, is that what you mean? Or
So like I'm thinking like the actual food itself, yeah, so the entrees, appetizers, that sort of thing. If we think of a menu, what kind of, when we open up a menu, we see food listed out, right? A menu is going to have that food on there. Um, and oh, how do I want to explain this? So you could underneath this menu have like food be one of the fields you enter data into. So you could enter something like steak, something like that. Um, but it could also be repeated if we have, so if we make multiple menus, and we have a summer menu that has steak and stuff on it and hamburger, but then we have a fall menu and now all of a sudden we have turkey and stuff like that, but we still have steak. We're going to have some entries that repeat itself, right? If we keep adding, like if we have a fall menu that we have steak on that, and then we make a summer menu and it has steak on that as well, we're starting to get into some repeated, we throw in steak a few different times on a menu, right? And we don't want the point of databases. And did you talk about normalization last time on Saturday?
We briefly went over dry, but not normalization, I don't think.
Okay, so when you find yourself repeating certain entries into a database, you want to try to pull that out of being a field and make it its own separate entity, if that makes sense. So like food, I can put in steak for this menu, but then I can have another menu and I'd have to put steak on again. It would be repeating steak multiple times in this database in these entries. So I don't want to do that. I don't want to have food be something I just enter in over and over. I feel like maybe you can almost think of it like selecting from a drop down. If I have like a list of foods, I can just click foods to add onto this menu, right? Um, that might be so I don't want to have food be so statically typed here. I want it to kind of just come from like a list of things I can pick and put on this menu. If that makes sense. So I'm gonna make something else called food items, or let's make it dish, the dish on the menu. Okay, so let's make this a little more clear to understand by adding in some fields underneath each of these.
So would it be, in this example, would it be something like the dish is all the foods that the restaurant offers all together, and then the menu is the current offering?
Yes, yep,
Okay.
in this example. So I got the syntax wrong here. It's supposed to pop up. How do I gotta look back at the tool real quick. Quick. Oh, I have to capitalize it. Why is it not? Oh, I guess we call it string, not varchar. Okay. The syntax here. Did that work? Wait. Oh, no, that's why it did work. It was just behind the other one. Okay. So we can have it be a varchar. So this we're thinking like type of menu, like seasonal or regular menu. Like, so if we made a menu and there's information stored in here, it could be the type would equal like seasonal, or type equals main menu, or type equals fall, you know, whatever. And then under dish, we'd have like name of the dish, right? So this would be like steak, salmon, you know, a name of a dish. Customer, let's add in here, name of customer, and we can have like email, I guess. Which is an email one. All of these, what am I missing? What is very important for our database tables? What field do I not have that we need?
IDs?
Yes, we need IDs. So a lot of times the way we write in Postgres, it's going to automatically create the ID for us, but we still want to have this on here and specify that it's going to be the primary key. What is a primary key? Like, what does that help us do?
Make things unique?
Yep. So a primary key makes things unique because we can't have two of the same primary key, right? It increments, and in most databases, once it's used, it's gone like forever. You can't ever use it again. So if there's something entered in and it gets an ID of 1, then 1 will never be available again, even if that item is deleted. 1 will always be barred from being used again. So that helps us with finding unique entries. And these primary keys also help us with relationships between the tables, right? Being able to reference another table and its information between these tables, which we're about to do here with this dish, but we'll look at the relationships between these after a little bit here. First, we're going to just set up what entities we need in this. So we've got our customer, our menu, our dish. We also need prices. So this is weird because making its own, and the README even tells us this, making a price table insinuates that the dishes are just going to have like a few set prices that you choose from. So we'd say like maybe appetizers. I think in the README they say appetizers are like $3. capitalization convention for field names. I'm not sure if there is for sure in this. This is just a diagram tool. In Postgres, I don't know if there is for our, I'd have to look at the Postgres. I always just type everything in lowercase when I'm working in SQL. Let me look at our, where is the README for today? Right here. I mean, everything's just in lowercase here too. I don't think it really matters just for the tables, I would assume. Those are all lowercase, but in our thing here, it's uppercase for the fields. I don't know. I would have to do a Google search to see if there's some sort of capitalization convention for SQL. I've never, I mean, so even like your select statements and all that, you know, proper SQL, you're supposed to do select in all capitalized letters, but nobody ever does really. When I write a query at work or when I look at queries in other applications, everything's in lowercase across the board. So, but best practice is probably to write the statements like they're supposed to be. I just don't know for field names if there's a capitalization convention for those. But that's a good question. And it's getting back to this. So for price is odd because we're assuming only has a few different price categories. By making this table like this, yeah, we're basically saying that we can only select from these prices here. It's really hard to discuss how to make a schema. I guess once we get into the relationships, it might get a little more clear here. But for price, which we're gonna come drag over here, we're just gonna have a value, right? That's pretty much capital, even though I don't know. And I think it's an integer. This primary key. Okay, so it'll have a value. Yeah, it even looks weird capitalized. I don't know. So every price is just going to have a value. So in this table, we'd see something like $3, $8, $10, you know, just a few different price values to select from. It's really weird, but for this example, that's what they want us to do. And then finally, we're going to have each customer, when they make an order, this order is going to hold multiple different dishes in it, right? So that's going to be its own table as well. We're going to have like the order, the customer's order. So we learned about, I think I saw in the chat, y'all discovered that user is a, not protected. What's the name of it? I guess protected could be a protected word in Postgres. You can't use user.
Reserved word.
Oh, I couldn't hardly hear.
It's like a reserved word.
Reserve, yeah.
Reserved function or whatever.
Yeah, yeah. Order is another one of those words. So I can't just put order as a table here, because when we get into Postgres, we may have some issues from that. So I'm going to call this restaurant order or rest order. So this also has our primary key. But then it also has, do we do that now? Dishes associated with it, right? So order will have dishes associated with it. But we can see we have a dish table here. So this is where we're going to start making our relationships between some of these tables. So we have a restaurant order that's going to have dishes, and I'm not going to define what that is, and a customer associated with it, right? It's not going to be like a customer is making this restaurant order, and this restaurant order is going to have different dishes on it. This app is called Quick Database Diagrams. So you can just Google it. It's a very nice little tool for visualizing. It won't be good when we go to make our SQL, but I mean, it can. It just, it's cheating. We got to try to do it on our own. Oh my gosh, I'm messing this up all completely. I don't like the README's way of going about this, so we're just going to do that this way. No, I guess we should do it their way. So it doesn't want restaurant order to be like this. I'm sorry. The only reason I'm not doing it this way and I'm doing the README way is because we're going to be doing some queries later. That's fine. We can draft up our own queries. We'll keep going this route. Okay, so we're thinking this restaurant order is going to have dishes in it and customers, but we already have a customer table and a dish table, right? So these obviously look like they have a relationship. And did we learn about relationships last week or Saturday? Probably Saturday, huh? Started looking at relationships between tables and fields.
The references.
Yes, the references. Okay, so we have 3 different types of relationships between fields or tables. What are those 3 different types of relationships? Do we know? So if I have one to many, all right, one to many and many to many. Those are 2 of them. There's one more, but we don't really use it much. Technically one more. It's going to be one to one. We don't really use one to one very much though. But we use one to many a lot and many to many. What does it mean by one to many? What are we talking about? Like a relationship that's a one to many type relationship between fields or I guess tables. So let's look at this restaurant order. And we look at customer here, and this restaurant order is going to have a customer.
Wouldn't it just mean that that one character of that specific topic impacts a lot of the other attributes within other classes?
So it's not that it impacts a lot of the other attributes, but that it can be used multiple different times within the table. So we can think of like this one customer is going to go in and place lots of different restaurant orders, right? So that's what we think of when we think of like a one-to-many relationships. This one customer can have many different restaurant orders. Yeah, it can be on more than one instance of a given table. I'd probably say more than one instance of an entry. So it won't be necessarily like, it can be in multiple tables, but that's not the one-to-many. The one-to-many would be entries in the database tables. So when we look at this design here, in fact, when it gets in the database in an Excel spreadsheet, it's actually going to be columns, right? These are each columns within the database, and they have data underneath it. So like ID is going to be like 1, 2, 3, 4, 5. Dishes are going to be like the names of the dishes, and the customer is going to be the names of the customers. So it's like an Excel spreadsheet table, but the other way. And each line then underneath is the entry associated with this table. And so when we say a one-to-many, we're thinking that this one customer can be on many different, records. Thank you. A record is technically the name for an entry within this table. So it can appear in multiple different records, multiple different lines in this table, if we can visualize that. So now, because we already have a table, we have a table with customers here that holds customer names and email and everything. We don't want to enter in every time the same customer name over and over every time they order. So instead, we're just going to take their primary key, which references their whole entry of everything about them, all the customers' attributes, and just pop it in this table here. We're just going to put the number in here. So that way, when an order gets pulled up, it will automatically see, oh, customer number 7 is Joe over here. I can see in the database, so it already has Joe's name, email address, everything associated with it. We don't have to write it in this table as we're entering the information in. So let's make a one-to-many relationship between the customer and the orders, because a customer can make lots of different orders, but an order will only belong to one customer at a time, right? So where does the reference go to in this one-to-many relationship? Because we're going to reference a foreign key, right? That's how we set up this relationship between the tables. And when I'm referencing a foreign key, what is that foreign key? Like, what becomes the foreign key that I'm referencing, or what is it?
The other table?
Would it be what from the other table?
Is it the primary key from the other table?
Yep, exactly. So the primary key from the other table is going to be a foreign key under the table it's referencing, or referenced in. So this customer would be the one referencing the primary key in a different table. So how we can write that here, there's a way to draw these lines. I don't know how to do that in this tool, but we're going to come over to our rest order, and customer is going to be a foreign key. How does it do it? Int foreign key, and then a little arrow dash to where it's referencing. It's going to be an integer foreign key, and then a little arrow dash to, now this customer foreign key is referencing that customer primary key, right? So it's going to be customer.id. And now we can see it drew the little line for me. So the one is over here on the customer side, and the little many hands are over here on the, I'm assuming it's a click and drag from this way, but so many times I've had the little many arrow, like, do me wrong. I don't know. But feel free to click and drag if y'all get it, but sometimes it just doesn't work for me, and that little many ends up where I don't want it to be. So that is one of them. That's one-to-many. Now dishes, same concept here, right? No, not the same concept. So this is going to be different. Let's think about it. How does a dish and the order relate to each other?
You can have many dishes in one order.
We can have many dishes in one order. Yep, that's right. Okay. But I can have many different orders doing lots of different dishes too, right? Like this dish doesn't just, I don't just have one dish in my order. Like let's say I ordered an appetizer, a bloomin' onion, as well as a steak, as well as a margarita. If I just have one field right here for me to enter it into, I can't add all those different dishes. So how do I, and then on the flip side, I can't really put order here under dish, right? I can't do order over here because this dish isn't going to be only assigned to one order. There's going to be 50 people wanting to order the same thing that I just did. So we can't restrict this dish to just one order all the time. It can go on many different orders. So this is where we're running into kind of that, or not kind of, we're running into a many-to-many situation here. Yes, exactly, a many-to-many. Because yeah, I could just have one dish on this order, but I like to eat a lot, so I'm gonna have more than one. The way this is set up like this, if I do a one-to-many between dish and the order, I can only ever have one dish on here. And then if I do the same on the flip side, this dish, if I try to do an order on the dish, then I can only have one order tied to this dish. This dish can't go out onto many different orders. It can only be on one. So we need to fix that. We need to do a many-to-many. How can we do a many-to-many? Can I just do something between these two tables directly? I need to have a junction object or an intermediary table to kind of act as a go-between. And this go-between table is simply going to hold the foreign key from one table and the foreign key from another table and tie them together as related. So I'm going to get rid of, let's see, oops. Oh, what did I do there? I don't know why it's, okay, good. So I'm going to get rid of this dish and order on these because I can't put values in here. I mean, he may have referred to it as an intermediary table. I don't know if y'all did a many-to-many relationship on Saturday. Did you? Do we remember? No. Okay. But this is where we're learning this because it just doesn't make sense to have a one-to-many, right? You have to think about it from both ways. When we first thought about it, a one-to-many with the dish seemed like a good idea. But then you got to think about it from the opposite way too, like from the dishes side, the dishes point of view. So this just doesn't make sense to do a one-to-many in either of these tables. We want to reuse multiple times across the board. So let's take them out. We're not going to have order here, and we're not going to have dishes on this. We're going to make a new table that's going to come up right here in between these two. And we are going to call, 128, we're going to call this order dishes. This whole table's only job is going to be to hold foreign keys from each of these tables just to tie them together. So each entry here is going to be an order and its dishes. And we're going to be able to add multiple entries targeting the same order. So we can, let's see, so let's add, we'll have our own ID because everything does, which is a primary key. And we're going to have order ID. Oh yeah, and we'll fix this naming convention, right? We don't want to name this just customer. We'll probably change it to something like this, like we do here. Order ID and dish ID. So entries in this table are going to look like, or records, I'm sorry. I'm not as perfect with my terminology for this, but they're going to look like 1, 3, 1, 2, 1, 5, and then maybe 2, 3, 2, 2, or so it's just going to be a whole bunch of numbers next to each other. And it's going to be the key associated with an order and the key associated with a dish, and it's tying them together. So let's say I place an order that happens to be order number 5 in this database. I will have then 5 and then a food item ID, and then 5 and another food item ID. And all that's tying it to my order that I placed, and then all the different food items on that order as well. And this might get easier to understand when we start inputting values into our database, or inserting values. So let's take away menu, because I think we got to focus on one menu to many and not a few here. So we're going to get rid of menu. Okay, so now with these, we are going to have a one-to-many relationship between this table and this table, because this order ID is only ever going to be one order, right? But this order can get placed lots of different times in this. We can order multiple dishes on this order. So I think we go this way, right? Nope, see, it did it the wrong way.
You could draw it the other way from right to left.
Yeah.
If you did it left to right.
That way. Okay. So you start at the one that is referencing and drag it over to what is being referenced. That's how you do your one-to-many there. So this is saying that this
I guess
restaurant.
Brian needs let into the meeting.
Oh, okay. Thank you.
Yep.
So this is saying that this restaurant order this ID can get used lots of different times in this table. It's not restricted to just being used once. That might have been a weird way to put that. Same thing here is this dish is being referenced. This is referencing. So we're taking where we are referencing and dragging it to what it is referencing here. So now in our table, we can see it did the foreign keys here. The foreign key is what is on the many side or being referenced. Is this super confusing to anybody, or are we following how this relationship's working here?
I think I just need to see it in code. I don't really get what we're doing until then.
Yeah, it will be a little bit easier once we start seeing the entries into the database for sure. But did we understand that, like, I didn't want to put a dish underneath this order because it limits us to just one entry into that record, like one dish entry? Do we understand that? And then we could say, well, maybe we can do a many to many, and so, or a one to many, so then we can have like an order under dish, but then it would limit this dish to only being attached to one order instead of multiple different ones. We'll keep going and we'll see if it gets more clear as we go on. Now this is also weird. Price. All these dishes are going to have a price, I guess. So we're going to just name this price ID, and I like just doing referencing a foreign key. And it's going to reference this price value from that one over there. Price ID. Okay, let's change this to be customer ID. Again, I don't like capitalizing. It looks weird, but that's what the app did. I don't know. Eyes are glazing over. I get it. Okay, so we have a customer coming in, and the customer will place an order that has a bunch of dishes on it, and each of these dishes has a price associated with it. Okay, overall picture. That's the schema. We are now seeing the relationships between these. So next, what we have to do is we have to actually write the SQL implementation of this. Don't worry about all those buttons up there. We're going to write it from scratch. But just keep this in mind. We'll go ahead and put this off to the side here. And then we're going to have our VS Code on the other side. Where's this one here? Okay. So how have we been making our database tables so far?
You've just been doing it from manually from the script. So up until this point, we've just been doing that the init file and then the seed file, and just writing create tables from there.
Yep, I like it. So we're going to keep following suit. We're going to make an init SQL file because we're also going to work through setting up our Docker container and copying this into there, or it's going to be copied in the Docker file, and then it will automatically initialize our database in our Docker container. So we are going to go all the way through that. Okay, so first things first, we want to create. Can I just go in and create the table right now in my init.sql file?
No, you need a database.
I need a database. Yes, exactly. So what do? What's my first line?
Create database and then database name, semicolon.
So let's call this one restaurant, because that's what we are making. Okay, so we're creating the database restaurant. Now, can I create the tables?
Not yet. No. Then you gotta connect to the database.
Then we got to connect to the database, yes. Create and connect to restaurant. Okay, so now we've created, we've connected. Now we can write our tables, right? Okay, so how do I create a table? Super easy.
You have to yell it. You have to say create table and all. Okay.
And then we give it the table name, right?
Yeah.
Okay, now what's in here?
Just customer ID, customer underscore ID. Will be the first one it looks like.
Okay, I'm going to make this an automatic thing. We're gonna let Postgres do my IDs. So there's a special way that I can have Postgres automatically create those for me. What's the verbiage to set up the field?
Is it serial?
Yep, so we're getting there. It's ID and serial. What else do we gotta say?
Primary key.
Okay, so this is how we tell Postgres to go ahead and just create that for us and increment automatically. So then we don't have to manually input IDs. Okay, so then we will put the next one, which will be name. So we have the name of the field we want first, and then we identify what type it is, right? So when we create table, then the table name, we say what the field's named and the type. So name, and this will be a varchar. We'll give it like 100 characters. Okay, next one, we're gonna have email, be an email. doesn't have email. Okay, I don't know what it is in Postgres. I can Google though. Postgres. Email in Postgres. What data type is that? Text or varchar. Okay. Well, then we'll use varchar. Okay, so well, that's all I had here. So now, does the order in which I create these tables matter?
It does. I found that out the hard way on Saturday.
100%. It does for sure. Why? Like what is the reason why?
Cascading. Okay, or is it the name of it? Where it just goes that's sequential and what it does, you know, it executes and references.
Okay, so we're on the right path with the cascade. When we delete, we usually need to cascade.
Well, if you're gonna associate with something else, the other one has to be present prior to.
Exactly. So if we have a reference to a foreign key, that you need the one created that it's referencing before you can go ahead and try to reference it. Otherwise, it won't say it exists. Like if I tried to do a restaurant order first, it would be like, we don't have a customer ID to reference. It doesn't exist because it will create from top down, right? It doesn't just see all around like Python does sometimes or JavaScript with the scoping. So customer is safe because customer doesn't reference anything in here, right? There's no foreign keys. It's not. It has it has a relationship here, but this restaurant order table is the one doing the referencing for this foreign key. So this one we were safe to create on its own. So restaurant order, does this look like we can create it next? Yeah, I think we're safe. I see head nodding yes, because all it references is the customer ID, which we've just created right there. So let's create that table next.
Does it matter if the variable name in there or the thing you're trying to create is blued out? Because I noticed that when it happened on Saturday, it was because that was already associated, like it was a reserved name and it threw the error. I just didn't know.
Yeah, it might. I didn't run into any errors today when I was doing this, so I don't know if it would for me, but being blued out, it does seem like it's a protected variable here. So we can maybe do like customer name.
Okay.
That way it's safe for sure. Good practice. Okay, so restaurant order, this one we're just referencing the customer ID. So how do I do this relationship, this one-to-many reference here? So the name we've established, we've named this field customer ID, but it's not, I'm not inputting a value. Well, I'm going to input a value. How do I write that this is actually referencing this customer ID?
Wasn't it just the word references?
Well, let's also put that it's an integer first. We need to say it's an integer that references customer ID or customer, I guess, parentheses ID.
I think you had to do like yeah, you're right.
Why is it customer ID at the beginning? Shouldn't it be ID itself?
So we have to tell what table it's coming from.
No, yeah. At the beginning, the customer ID, at the reference.
At the beginning. So this one ID.
Yeah, isn't that supposed to be in the bottom since it's The primary key. I'm just saying because what do you have the customer ID as a primary ID, a primary key?
This is, I'm not exactly following. This ID is the primary key for this table. And then this
Right.
ID is the primary key for a restaurant order.
Yeah, I'm talking about the customer underscore ID. What's that?
Oh, this is the name of the field.
Oh,
So like I have email, that's the name
okay.
of that field. So customer ID is just its name, but it's only going to take in an integer that references the primary key from that table.
Okay. Thank you.
Mhm. Okay, so we got that one set up. That looks good. Can I create this one next? This order dishes. We can see the relationship between restaurant order and order dishes. I've covered that. I'm good there.
I think you still need dish first, right?
Yep, I definitely need dish because it references this over here. So let's look at dish. Can I do dish then? Can I create this? Let's see. We see a relationship here, and it does have a foreign key referencing over to price. So I can't create dish yet either because I don't have price set up to reference. So now let's look at price. This one. This one looks safe, right? There's no foreign key references here. It's just its ID and a value for the price. So let's set up price next as our next table. So create table price. This is going to have the ID. And it's just going to have a value, which I guess they have as an integer. It looks like value is reserved as well. So let's do price value. Okay, so now that I've created price, I can create dish because that references price. Create table dish. That's ID as well, serial primary key. And this is going to have the dish name, which will be bar car. And then it also has the price ID, which is going to be an integer references the price ID. Okay, so now lastly, we have order dishes. That's our last one to do. So create table, order dishes. So we're typing that out over and over. So this one we can see has order ID and dish ID. Which is, this is also a reference to the restaurant order ID. And then not price, dish ID references dish ID. Okay. I think that looks good. What am I missing from like everything though?
Semicolons.
Yes, exactly. We would have found that out very fast. Missing semicolons after all of these SQL statements here. Okay. Looks good? Yes. I think it looks good. Okay, so now after we do that, let's go ahead and write some seed data. So kind of what you've been doing, like seen in some of the other init SQLs, has some insert intos below. So let's write some of that now. I wonder how many we want to do. That is a lot. Okay. So how do I add some records into the customer table here? How do I insert into that table?
Insert into, and then the name of the table, and then all the values or the fields that are in the table.
I had what I wanted to make sure we add in there for our queries later. Where did it go? Oh my gosh, they're not very organized. Oh well. Okay, so we have insert into. Oh, and again, see, it should be all capitalized, but I have not in my job done this. But insert into the name of the table, customer. And then what did you say next? Sorry. Oh, you're muted now.
All of your field names, so ID, customer name, and email.
Email. Do I need ID in there?
No, I think so.
No, I don't need ID in there. If you provide ID, it will expect a value to be passed in. However, because we have ID serial primary key, you don't have to. And sometimes that can save you some headaches. I've actually rewritten several queries or several inserts and stuff that failed because it was expecting an ID that wasn't provided. So you don't need to feed an ID in. It will just automatically do that. It will automatically do that. Yes. Oh, V, you've actually done that where you didn't provide an ID and it failed. But for us, no, we're not going to. We're not going to pass it in because I don't want to. That defeats the purpose, right? If you did provide that, I think I saw it on Saturday, that y'all were adding default for the ID. Was that right? Makaroo? Oh,
Yeah,
no.
that's how the Craigslist example had was the default,
Yeah.
but it was in the actual entries. It wasn't in the insert into line.
Oh, okay. Okay. So if you specify ID, you do have to pass in ID. Yeah, it did have insert into app view. Okay. And then has default and then the names.
So you could either leave it blank or you have to put that default.
Yes,
No.
you can give an ID, but it would not. You should never give an ID manually. So yeah, either leave it off because then it won't expect you to pass that value in and it will just automatically create its own. Or if you do add ID, use default, and I guess it will default to the serializing it, or I don't know how that works with the default. Obviously, it just does default actions there. So with customer name and values, yes, we could use something to help us seed the data, but I want to be intentional about this and really understand what we're putting in here. So let's give a name. This will be Randy Johnston. And we have email. Oh gosh. Randy@gmail.com. Sure. Okay, so there's one. Now we're just gonna copy this. We're gonna do 3 more. Seating random people in here. Jordan too. Jordan. Okay. So next we are going to create some restaurant orders for the customers. So we'll insert into rest order, and this expects customer ID. All right, that's easy enough. Do work. Okay, yeah, we'll just and it takes just the reference, which is an integer. It's going to reference primary key. So we should, when we create this database, only have 1, 2, 3, 4 as our primary key values, right? So we can only see data 1 through 4. So we're just gonna create some orders here for these customers. Now I can see why in the README they had also what did they have? Order date. And it be, let's look at the README here. That's a timestamp. It's time zone. Okay, default. Wow, all this it looks like it's just taking in the current time. We're not going to do that. Do we have date time? Yeah, we'll use that. Okay, so the README has this order date in there. We didn't create this, but that's because this customer could come in on a different day and order again. Okay, timestamp, I guess, of when they ordered. So this first order is going to be done on 2025. Let's see, 12. Sure. And be placed by Randy. This one's gonna be put in on 10:30. Okay. There. This is a little better. So now this is saying that, Randy came in on December 25th and ordered. And then Randy came in also on May 5th and ordered again. So each of these orders are going to have different meals associated with them, which we will do in just a minute. Let's first make some prices for our dishes. Insert into price, takes in just a price value. And we're just going to have 10. Oh my goodness, I need to be doing this after each one. Oh, we're almost at the end. Promise, hang in there. 8 and 3. Okay. Okay, so there's our prices. Now we're gonna go to the dish. Insert into dish, which has a dish name and a price ID. So we can do this one at a time like we've been doing, but you can also just do like multiple entries at once. You could insert multiple records with different entries in there. So like we can say this burger is going to be $8, which should be the second ID. We're gonna guess because we don't know, but it should insert these like 1, 2, 3 for our primary keys. So we can do burger, but then we can comma, come down to the next line, and we can do another one without having to do insert into every single time. We just set up the structure here first, and we can do values, order date in the creation. Let's see. We added order date to our restaurant order, which I did add. Oh, yep, exactly. Thank you for pointing that out. I do need to have that here. Okay. Pasta is going to be also to, let's do a salad, be free. Okay. And then we'll do steak. I'm using that a lot. That should be our most expensive one of 1. Okay. So we can also do it like this as well. Values and then just string them together with commas separating. I lay it out like this so it's easier to read, but again, white space doesn't matter. In SQL, it just ignores white space. You can have this all in one line and it would still process it the same. Okay, finally now we are on to ordered dishes. So this is the one where we had that many-to-many going on. And it was a little weird to think about, right? So let's insert some values into that now. Order dishes. And it takes order ID and dish ID. Okay. Values. So now everything I add here is going to be a reference to one of these others. So let's look at order ID first. This should become 1. Like it should have an ID of 1 because it's inserted first into that table. So this order that was placed by Randy on December 20th, that order 1, let's add a dish of a burger on it, which also should be 1 if it's inserted into the database 1, 2, 3, 4, right? So these entries are just going to pick a dish out of our list and an order out of our list and just tie them together. That makes it a little more clear. So let's use the same order placed on December 20th that Randy did, but Randy also got a salad as well, which should be 1, 2, 3. So this is how we are able to add multiple foods. The second row is the dish, that's our food, onto the same order over and over again. But now on the flip side, we can go to a different order and add the same food that was ordered by Randy. So it's just allowing us to make that connections between items we have in this database or in this table with items in this table. Does this kind of make it a little more clear on how this many-to-many, I can try to describe it in a different way as well. I like to, oh, go ahead.
Can I take a look at the tables real quick, please? Oh, the map.
Oh, okay.
Thank you.
The diagram.
It will be our issues.
So how come steak is one? Oh, because it's the most expensive.
Yeah, and so it's that second value here in this
Is
entry
reference.
is, yeah, referencing the primary key of the from the price table.
Got it.
And then these are, both of these are referencing primary keys from their respective tables. Okay. How are we feeling about the many-to-many? It's a little bit difficult, but once you start using it more, I think it'll get a little bit easier. Sometimes I like to think of it as like if you were in a computer system and you have a drop down and you can select something. Is line 50? Okay, I'll fix that. Yes, it is. But if you have like a drop down and you can select something, that's like where you'd reference a foreign key value, right? So if you're able to go in and kind of select an order and then select a dish to put on the order, that right there makes me think of a many-to-many relationship. Whereas if you just had, I can't think of another example right now. I can think of more later. Okay, insert into. But okay, let's make a few more just so order. So order IDs, we have 3 orders. So let's do one on the 3rd order. And they're gonna get the pasta, which is a 2. And make it all uniform. Okay. So we did this because otherwise, if we had food in our restaurant order table, if we tried to insert stuff into this, we'd have to do something like this. And then that would be the only food it could have. It wouldn't be able to have multiple foods saved to it. And that's why we're doing this in between table. Okay, I'm gonna keep going unless if people want me to try to explain a little more or do something differently for the many-to-many. So maybe we could do it like this. Randy ordered a burger. Randy also ordered a salad. I don't know why I capitalized that. So maybe that helps kind of see that's what these are doing here. Randy's order and then the food items associated with that order. Okay, so let's move on now. We've got our insert statement that we just did. We're good there. Our seating data, but now we actually need to like make our database and seed it with this information, right? So we've been doing that with Docker, correct? So my next step would be to have a Docker file in here. In every Docker file, we start off with, okay, I can't act like this is a Saturday. I'll keep trying to work through the lecture quickly here. I was hoping we could review all this Docker stuff and the setup and all that a little bit better, but I'll just kind of fly through this at this point. In every Docker file, the first thing you're going to do is specify which image you're basing it off of, and then you'll move on from there. So we're creating a Postgres instance, right? We want to spin up a container that holds a Postgres instance for us to use, so we're not running it on our local machine here. We're using this containerized version of it so that we can use it and it works everywhere. So we can reference back to the cars database, or if you go into today's example, or not example, today's example, the restaurant database one, you can look in there and it has, we're pretty much just gonna always copy from Postgres 15 or latest, right? This is the version number that we're targeting for the image. But if you just put latest afterwards, it will grab whatever's the most recent one, most recent stable build. I'm gonna go ahead and just grab 15 because I know that works because I used it earlier. So we say what image we're basing this off of. And then next we can see in our little example that it had, I have too many tabs open, does this copy. So this is something, if you read the documentation for the Postgres Docker image, it will say, if you want to have an initialization script for your SQL database, place it in this location. And it gives you this command. So this is just what this container expects. So it knows when you place this init.sql file here, it will go ahead and run this automatically. It's just what it does. It's in its documentation. So we're going to copy that as well and put that here. And this is all our Docker image needs to be. We're using our base image Postgres. We're copying this SQL script into there, which will automatically run and set everything up. So that's the first things first. Next, we could do all of our commands to get this image built and running in the terminal, but we're going to probably make changes to things and do some rebuilding and, sharing and having those people build it. So it's always nice to have that setup script to go ahead and run all those commands for us. And again, we can use today's example one and look at how they do it. So in these setup scripts, it should stop and remove any existing containers. Who can tell me where in this it stops and removes existing containers?
Is it the RME?
Yes, it's this RM. So this RM is a flag you can add on to the Docker command that once you stop the Docker container, it will actually remove and delete it. So this is optional. If you don't have this in here, when you stop it, the container will remain on your local host and you'll be able to just spin it back up again. But having this there, when you stop it, it deletes it. So that kind of covers that. So we have that stop and remove existing kind of built in to this run command. We should also have it build the image, right? We need to build the image first and then run the container from that image. So this line here is building the image. What is this T restaurant DB? What is that?
The tag, what you want to name it.
Yep, so this is the name of that image we're building. We're giving it that tag so we can reference it later. What's the dot?
Do it here.
Do what here? What is it looking at when I say Docker build?
Looking at your Docker file.
Yes, exactly. So it's going to look in the current directory you're in for something that says Docker file and run that. So we build the image based on how we wrote that Docker file. Next, we're going to run the container. So we can see Docker run. This name, pgdb, this is what we are naming the container. It's kind of like how we gave a tag here for building the image. Now we've given it a name for the container so we can use that later. This -e Postgres password equals Postgres. This is something that this Postgres container expects to be passed in, and this is in the documentation as well. It tells you it has to have this. This E is an environment variable. -e means it's setting this as an environment variable in this container. So it just needs this to work. That's what documentation tells us. Dash D is in detached mode, so it's not going to eat up our terminal. And then this last thing here, that is where we're telling it what exactly to run. So what was this from? When it says Docker run, blah, 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 restaurant DB, where do we get this?
That's the container that you built.
That's, yep, this image that I built up here. We gave it that tag restaurant DB. So we are just saying, go ahead and run that image. Now we sleep for 5 seconds to give time for this to build and run. And then we exec into it. What does it mean, exec into the container? What does that look like when we do that? So in this instance, when we exec in, we're also calling PSQL. So when you run this, where do you find yourself after you run this setup script? What does your terminal look like?
You would say rest or whatever would be inside the root file, you would be within that database, right? So you'd be within restaurant.
Yep, exactly. So execing in, and it specifically in this case, using this PSQL to pull up into the restaurant database, it's bringing you into the container that's running, and you are jumping right into a Postgres terminal into that restaurant database. So you can also exec into this container into Bash. And you can end up then inside your container, and it looks like a regular terminal that you'd see in your VS Code, like on your local host here. It would look like this, but it would be inside your container. So you can go into Bash in there. You can go into the Postgres. It's just entering into that container. Okay, so we're just going to copy this to save some time. And throw this into our, where is it? This is the one we just wrote. Yes. Setup script here. Okay. And this should be good. We'll name it restaurant database. That's fine. And containers. So how do I check to see if I have any images on my, right here, right now?
Docker image ls.
Image ls. Okay, you can also do Docker images, is the same thing. So I have nothing. I have no Docker images. Sweet. Just to be sure, let me check and make sure there's no containers running either. How do I check containers running at this point?
That Docker PS.
Yes. So this will show me currently running active containers. What about, how do I see containers that exist but are not running right now?
You just open the Docker app and look. Because you
You
can't
can-
remember.
You can add an A tag to it. So this will show you the ones that are stopped and not running as well. But I have nothing in here because in my my bash profile here, I have a wonderful clean function that I wrote that will stop and remove all images and containers from my system. So if y'all didn't add like a clean, I don't know if we had that in Install Fest. I'll show you afterwards how to do this, but it helps clean up your system if you ever get too many things running in there and you don't want to do Docker RMI and all that stuff. Okay, so let's run this setup file and the setup script and see if it builds our database then. Let's make sure we're in the same location as it just to check, which we are. Looks like I don't have permission. So what do I do when I don't have permission to run this file?
Chmod it.
I chmod it. Does anybody know the chmod? the code for this?
Just plus X.
Plus X. I haven't done it that way. I've done like 744 and then set up.
Give it the old 777.
What is it? LS-LA? I don't. Yeah. Okay. So now we can see that that went ahead and gave me the execute permissions on here as well. First one's us, right? Second one's like group, and third one's like everybody else. So we're definitely concerned about this first thing here. We have X now on our setup, and we can see it's green. Okay, let's do setup and let's cross our fingers and hope our container builds successfully. Error, no such container. Okay, so what should I do first when it says no such container? I'm going to look at my containers. That's what I'm going to do first. We can see I definitely don't have a container. Okay, let's look at my images. It made the image, but I could not create the container. So what do we think is going to be the problem then? I will tell you, if you make an image, yes, exactly. If you make an image successfully and your container does not get up and running, 99.9% of the time going to be something in this init.sql file. Something is going wrong, and of course we can't see because we're running in detached mode. Let's take off detached here. And I don't even need to run this whole script again, right? I'm just going to try running this Docker container and see what happens. Okay, so now that we didn't run in detached mode, we can see the output in my terminal of what's happening with this. So I just ran, I did a Docker run, but took off the -d. Okay, so database server to start, good. Create database, we're connected as Postgres, create table, type date time. Okay, so I guess date time is not a type in Postgres. I gotta figure out what the type is for dates there. I think in the
It's just date.
It's just date? Okay. So let's go ahead and do that. It made it blue, like it looked like it was going to be. Right. Okay. So this is nice because look, it tells us, and this is the good thing about writing in a SQL file, is it actually points out where the issue is, right? It gives us a little more information than just doing it in the Postgres terminal itself. Okay, so let's try to do this again. Now, can I just, do I have to do this whole setup script again, or can I just run line by line from some point? If the issue is in my init SQL file, can I just try running my container right now? Do we think that will work?
Wouldn't it not work because you've already got a thing created, so you would need to run it to remove it?
Yeah, so I have, as we saw, I created a Docker image, right? This image, so if I try to just run it, it's going to run this image, which this image, we already copied an init SQL in to create that image. So if I made changes to this and I don't rebuild the image, it will just be that old init SQL in there. So since I made changes, I need to rebuild that image to make sure that the new changes get brought in there. So let's just run the whole script again. That's easiest instead of going line for line. Oh, I should have shutting down. Insert into, it looks good. Yeah, we created table. Inserted. Let's see. Let's go. I should have run in detach mode. That's my bad, but we'll go ahead and Docker PS and see that the container is running right now and it's up. It's been up. So it should be good to get in. But since I didn't run in detach mode, that terminal didn't let me exec into there. So I'm gonna exec in this here. Okay. All right. So now that we're placed in our Postgres terminal. Let's go ahead. We can select all because we know how many entries we put in here, but I would not recommend doing this. Actually, let's see what tables we have. How do I see what tables I have in this database? Does anybody know the command?
DT.
Yep. DT. Okay, so it made the tables. Okay, that's good. And we can also take a look at a specific one and go ahead and /d the customer gives us all the fields within this. And even our indexes, which makes looking up things really fast. We won't learn about that much in this class, but it's neat to look at on your own. And then our references as well, our foreign key references. Okay, so that is all I will do tonight because I've eaten up a lot of time and I want to leave y'all the last couple hours to try this on your own. Let me stop recording while I show what we're gonna. Any questions though? This is pretty much what you're gonna be doing on your own for a different prompt. Nope. Okay. Let me stop recording real quick.